Find the largest contiguous subarray using the sliding window approach. Here is your same structured beginner-friendly content for Find the largest contiguous subarray, sliding window approach, Kadane's insight, introduction. One of the most classic problems in arrays is find the contiguous subarray with the largest sum. This is also known as maximum subarray problem, largest contiguous subarray sum. This problem is important because it teaches optimized array traversal, dynamic window expansion, handling negative numbers, Kadane's algorithm, core concept. It is widely used in financial analysis, max profit window, signal processing, data analytics, coding interviews, problem statement. Given an integer array R, find the maximum sum of any contiguous subarray. Example, error equals -2, 1, -3, 4, -1, 2, 1, -5, 4. 6. Subarray 4, -1, 2, 1. What does the problem mean? We need to find a continuous segment of the array such that sum of elements is maximum. Elements must be contiguous. In simple terms, largest contiguous subarray equals continuous part of array with maximum sum. Why sliding window? Traditional sliding window works well for fixed size windows. But here, window size is not fixed. Negative numbers can break the sum. So we use a dynamic sliding window approach, Kadane's algorithm. Core idea. Current sum equals max element, current sum plus element. This decides whether to start a new subarray, extend the current subarray, brute force approach. Check all possible subarrays. Steps: generate all subarrays, calculate sum, track maximum. Complexity, O(n)². This is inefficient. Optimal approach, Kadane's algorithm, sliding window style. We maintain. Current sum means sum of current window. Max sum means best result so far. Step-by-step logic. Step 1. Initialize current sum equals 0. Max sum equals -infinity. Step 2. Traverse array. For each element, current sum equals max I, current sum plus Ri. Max sum equals max sum, current sum. Step 3. Continue till end. At every step, if adding current element improves sum, means extend window. If not, means start new window. Example concept. Negative prefix means discard. Positive growth means continue. Java implementation, public class maximum subarray. Public static int, max subarray int R. Int current sum equals R0. Int max sum equals R0. For int I equals 1. I greater than R.length, I++. Current sum equals max, Ri, current sum plus Ri. Max sum equals max sum. Return max sum. Public static void main string args. Int ru is -2, 1, -3, 4, -1, 2, 1, -5, 4. System.out.println max subarray R. Output 6. How the code works. Initial values. Current sum equals -2. Max sum equals -2. Step-by-step updates. 1 means max 1 -2 plus 1 equals 1. -3 means max -3 -3 equals -2. 4 means max 4 -2 plus 4 equals 4. -1 means max -1 4 -1 equals 3. Max 2, 3 plus 2 equals 5. 1 means max 1 5 plus 1 equals 6. Final answer, max sum equals 6. Sliding window interpretation. This is a dynamic sliding window. Extend window means if beneficial. Shrink reset means if harmful. Time complexity. We traverse the array once. O(n) space complexity. Only variables are used. O(1). Finding the actual subarray. To track indices, int start equals 0, end equals 0, temp start equals 0. If error I equals current sum plus error I, current sum equals error I, temp start equals error I, else current sum equals error I. If current sum, call it max sum. Max sum equals current sum, start equal temp start, end equals I. Real-world applications stock market, find maximum profit window. Signal processing, detect strongest signal segment. Data analytics, find peak activity periods. Example concept. Continuous data means best segment detection advantages. Advantages include optimal performance, simple implementation, works with negative numbers. Example concept. ON solution means very efficient limitations. Challenges include not intuitive for beginners, requires understanding dynamic decisions. Example concept. Local decisions means global optimum. Common mistakes, using fixed window. This problem requires variable window. Resetting incorrectly. Do not reset sum blindly. Not handling all negative arrays. Must initialize with first element. Example concept. Incorrect reset means wrong result. Concepts learned. Dynamic sliding window. Kadane's algorithm. Handling negative numbers. Optimal subarray selection. Linear time optimization. Simple definition. Largest contiguous subarray. The continuous subarray with the maximum possible sum. Final summary. The largest contiguous subarray problem is a classic example of an optimized sliding window technique. Instead of checking all subarrays, Kadane's algorithm dynamically decides whether to extend the current subarray or start a new one. This results in an efficient ON solution. Understanding this problem is essential for mastering array optimization, dynamic programming, and sliding window techniques.